very pleased to introduce EMPHASIS and showcase some examples how EMPHASIS or phenotyping is important on a global scale, and the interaction with Australia is particularly important in this sense. So what do we do? Select phenotyping. What we specifically do, selection of a phenotype. It's a basis for breeding. This is talking about Australia. I start with ancient Egyptian. They already do the same what we do conceptually already now. So selecting plants with or better properties, or properties that are used to grow, to produce a higher amount of plants, higher quality, quantity of plants. This has led in the end to domestication over the last 10,000 years. And in the end, after the Mendel's heritability rules and modern genetics, it ended up in green revolution, which is well known to you. But there are still many challenges beyond just providing food. So plants is one of the keys to many major societal challenges. For example, global change, climate change, the population is growing. It's not only that we need to provide food, but plants are also sequestering CO2. And crops, on the one hand, produce CO2, but they are also agriculture produces CO2. But on the other hand, they are also affected severely by climate change. There is limited land available, so it will not be possible to increase the agricultural land to grow more plants. Additionally, fossil resources there is a transition from fossil to bio-based resources, which puts additional pressure on crops and novel demands towards quality, quantity. So bio-based resources are used more and more, and there is an increasing demand to use bio-based resources in many different scenarios. So in this context, plant phenotyping, what we specifically want to do, it's to make it simple. So plant phenotype, we want to understand the genotype environment interaction. When you break this into the variance components, then you have this genetic component, but also this plant component with this environment, and understanding this triangle. It's basically a key to understand plant performance, plant production, higher quality, quantity of biomass, novel characteristics, products yielding in stressful environments, sustainable production, intensification under stressful conditions, and also lowering environmental footprint. In this sense, understanding this triangle, Australia and Europe were pioneering the developments. So first national plant phenotyping infrastructure emerged in Australia, which was the APPF, Australian Plant Phenomics Facility, in 2009, already over a decade ago, followed by developments in Europe, so in Germany and France. And those were the three basically leading infrastructures that developed, shaped plant phenotyping. The interaction is ongoing in many different projects, like the International Plant Phenotyping Network, basically linking the phenotyping activities across the globe, as well as G20 initiated wheat initiative, which also focuses on improving wheat properties, where Australia and Germany play the key roles. It's also interesting that, for example, the international conferences on plant phenotyping, 4 of the 7 were held in Europe or Australia. So basically, those are the key hotspots for plant phenotyping. This is also, when you look at the publications in this map, you can see the publications in the last decade. So in Europe, 42 papers were published in Europe, 6% just in Australia. But when you convert it into related to the population, then which is indicated by the color, Australia is by far leading the publications in this field. This also led to the development, particularly in Europe, to the Starting Community Project, EPPN, which was integrated the community, provided access to phenotyping facilities, and Australian partners were included in this project. which followed up by EPPN 2 or EPPN 2020 as an advanced community grant, which further development of standardization, tool methods, access to platforms, where additionally Australia was included, and leading in the end to EMPHASIS as a S3 roadmap with S3 project with a long-term operation of a pan-European infrastructure. The concept that we follow, and I think this is very, very common between Australia and Europe, is covering a range of scales from single plant to controlled environment and to the extended field areas, and link those to data management, modeling. They are community standards, data management community standards that were developed such as BRAPI, MyAPI, that were developed within a framework of this collaboration between Europe and Australia, and they are represent the key for fair data. In Europe, to give you some overview what's happening actually in EMPHASIS, and which builds on the developments with Australia. So we have in EMPHASIS a number of different infrastructure categories. Categories of plant phenotyping facilities on the controlled environment, field facilities, modeling, and intensive field, quite a wide distribution in Europe. To give you very briefly a flavor of what we specifically do, let me briefly go through these installations or to the infrastructure categories. So in controlled environment, what we specifically focus on is facilities under controlled environment in greenhouses, growth chambers, and try to cover a pipeline from seeds in the end to high throughput phenotyping under controlled conditions. Screening to 10,000 or 1,000 on more plants. In a field, we have two categories of field facilities. On the one hand, intensive field, where we have phenomobiles, which can, for example, which can measure plant properties with high precision under basically field conditions, as well as facilities where you can control the environment to a certain level. On the right-hand side, you can see a phase facility where you can increase within a ring. You can increase the CO2 concentration under normal ambient conditions in a field up to, you can double the CO2 concentration, and see measure the response of those plants, different crops to the elevated CO2. Obviously, there is also a lean field. So lean field, it's more closer to breeders applications. So it's a quite often affordable solutions for phenotyping, but there are large advantages that we can link different field sites and do experiments along environmental gradients. And this physical facilities, they are complemented by a modeling infrastructure where we use those data to generate and validate different models. What you can see, the model here, for example, it's 3 different crops, plants growing in a soil. The yellow color indicates the nitrogen, and you can see how roots grow in soil, how they develop, how they explore the soil. And currently there is a number of over 100 different open source models which are available for the community and can be used for different plant phenotyping and not only phenotyping applications. Finally, data. There is lots of discussions about data. So what we are developing is also common standards to make data fair. So basically having common unambiguous identifiers, so controlled vocabulary and web services that enable access to all those data that were produced in this other infrastructure categories. Those points in these different infrastructure categories, as well as many other interesting aspects related to plant phenotyping, they were discussed this morning. Actually started at 6:30 this morning. They were discussed with colleagues from Australia. We had a plant phenotyping workshop where we discussed many different aspects. And so far, there were already a number of bilateral agreements, memoranda of understanding available between Australia and different institutions in Europe. Right now, we are working on developing a memorandum of understanding to put an umbrella around that and link EMPHASIS and the Australian plant phenomics facility, and we discussed a number of topics, and with those we will advance plant phenotyping. So the basic idea is that we have phenotyping and environmental observations that are included as a phenotyping under controlled conditions, field conditions, soil, roots, and provide coordinated services such as access to those services, access to tools. The other aspect is working on automation, robotics, sensing, harnessing innovation related to, on the one hand, new technology, but also evaluation, analysis of data related to this technology. And finally, multi-scale approaches where we look at using this data modeling, using a multi-scale modeling approaches relevant not only for phenotyping, but for agroecosystems, for climate change modeling, for sustainable plant production, which we are working on right now and hope to advance such not only a collaboration between Australia and Europe, but as such also advanced plant phenotyping at large. And as such, that was a short overview of what's happening in plant phenotyping, collaboration between Australia and Europe, and I'm happy to take questions.